GitHub AI with Damian Brady.
The Azure and DevOps podcast is a show for developers and DevOps professionals shipping software using the latest in .NET, Azure, AI, and DevOps. Listen on to learn how to increase quality, ship quickly, and operate well. The show is sponsored by ClearMeasure, a full-service software architecture and engineering firm. Find them at www.clearmeasure.com. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. My returning guest is Damian Brady, and he's been on the show several times before, most recently in episode 306. We'll include a link to that in the show notes where we talked about everything GitHub Copilot. But Damian Brady is a staff developer advocate at GitHub. He's a developer, a speaker, an author. He specializes in AI, DevOps, MLOps, developer process, and software architecture. He was formerly a cloud advocate at Microsoft for many years, and before that, a dev at Octopus Deploy, and he's been awarded the Microsoft MVP Award, and he has a multi-decade and counting background in software development and consulting in a broad range of industries. In Australia, he co-organized the Brisbane Net User Group and launched the annual DDD Brisbane conference. Has really been a community instigator and leader, and really excited to get him back on the show. So, Damian, welcome back to the show. How are you, sir?
Thanks. I'm doing well. How are you?
Fantastic, fantastic. I'm excited to talk about AI and what's going on in GitHub. But before I kind of ask you about that, some of the listeners have heard you speak before, and you've spoken at NDC and all kinds of other conferences. But for those who haven't, if you were to kind of go back in your career, because you've been doing this a while, you've been in the software world, coding world for a long time.
Yeah.
Is there one thing that I don't know, just grips you that actually keeps you in programming?
Yeah, I think so. I always used to say that I'm an okay programmer. Like, I can write code. It's a lot easier now with Gen AI stuff, Copilot and the rest of them. So I was an okay programmer. But I got a lot of interest, especially at Octopus Deploy and then Microsoft and now at GitHub as well, about around all the things that surround your software development. So all the processes and the good practices and stuff around the actual writing of the code. So, I mean, a lot of people probably know me from DevOps, world around. I was in Donovan Brown's team for a while at Microsoft, and we talked a lot about that whole process and how do you get trustworthy, repeatable process to get software out the door and into the hands of users, and then being able to, validate that that's good and it does the right thing. And if it's not, then being able to kind of iterate really quickly and get that out the door as well. So I don't think any of that process has changed, and that kind of, it's changed a little bit, obviously, but I think the principles behind it are still incredibly solid and really valid. And so that kind of keeps me going. These days, I write a lot less production code, a lot less meaning close to none. Just vibe coding something is totally feasible for what I'm doing. But, there's organizations that still need to push out good quality, trustworthy code. And so that's the bit that kind of keeps me going, is how do you do that when everything else is changing?
Yeah. Yeah. Well, I think I want to ask you about the state of AI at GitHub, and I think the whole industry is really internalizing Copilot in its various forms, and all the other competitors, and y'all are competing really fiercely with Cursor and Claude and Junie, and which is great for developers because everything's getting better, and developers are internalizing that. Oh, wait a minute. I used to do Google searches for stuff. I used to search documents. I used to do this. And now it's almost like, why would I ever go out of my IDE to do a search? Or how does this API work? Or it's right there. And so that's a big transition. But you're in all the meetings at GitHub. Can I start with asking you, what is the vision? What are you guys talking about internally for how the software development lifecycle is going to change? Maybe not, next month or even this year, but what's your vision for how AI is changing software development?
I think it's actually kind of going along the lines of, well, what other stuff can we use it for, and how do we make it more trustworthy? There's a couple of things to talk about, I suppose, but really early on, like in the first days of Copilot, it was pretty much just a powerful autocomplete, right? It would kind of predict what you wanted to write next, and from there it moved to being more and more trustworthy in that respect. But then there was Copilot Chat, and then that kind of got folded into the same product. But over the last little while, we've started adding other areas where generative AI can be useful. So things like code reviews, and we experimented with a thing called Workspace for a little while, and then that kind of got folded into being able to just assign issues to Copilot, or even just ask Copilot to do some tasks. So a little bit more hands-off. So these are, it's kind of expanding what we expect generative AI to be able to do. And we're generally pretty careful about where we put it. We're not just throwing a chat, window onto something else. We're tuning what runs behind it, so that when we do something like assign Copilot to a pull request to say, can you do a code review? It's using, some fairly mature, rules and plans and processes and things behind the scenes to be able to do a good job of that work, rather than just, throwing the context at an LLM and seeing what comes out. So that kind of, expanding the footprint of what Copilot can do. So we're not just writing code now, we are reviewing code, and we're doing things like locating bugs. There's a Copilot autofix in GitHub Advanced Security as well. So not only do we do things like identify that there's a potential vulnerability in some code that's been written, we will suggest a fix for it, and then you can merge that fix in one hit. And things like that have meant that Copilot's kind of involved in more of that software development lifecycle, and in some cases, preempting it. So it's not just a, hey, can you go and look to see if there's something wrong? It can come to you and say, hey, I found a security vulnerability. Would you like me to fix it? Here's a solution. So I think that's the overarching, we're expanding that kind of work. The other aspect of it, I think, is that we are looking a little bit more at this kind of next stage of, we can generate all of this code, that's fine, but how do we validate that it does what we want it to do? There was a really interesting internal chat actually in Microsoft, across GitHub and Microsoft, and I think it was Asha Sharma who runs, I should have looked up her title before, but she runs a lot of the dev div stuff. So she's like my boss's 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 boss kind of thing.
Oh, wow.
She referred to this as the evaluation part of the problem as well. So we have the, execution, so we can create code, we can create, we can fix bugs, we can do all that sort of stuff. But then the evaluation step is a tricky one as well. How do we evaluate that what's been done is what we need it to be done? So there's a lot of effort going into that. Things like Work IQ, which allows you, it's a relatively recent release, which allows you to kind of hit your internal M365 systems to pull out real information via MCP or something like that. So you can, in your code, ask things like, well, what is my team said about this particular issue, and it will look through Teams and emails and all sorts of stuff to get real information, and that allows us to validate what we're doing is actually the correct thing. So there's that side of it as well. So we've kind of looking at other opportunities for what Gen AI can do to help us in that whole life cycle rather than just cutting code, and then also looking at how do we validate, how do we evaluate that it's correct, and that we're doing the right thing with the right data. I think the two kind of areas across the org.
One thing that I ponder about is, are we going to do the exact same steps, but just some of those steps are automated? Or does something about the right process actually change? With the example about test-driven development.
Yeah.
Starting back in 2004, I and so many other people in the industry got into the test-driven development cycle, where you actually create a test that fails because you haven't written the production code yet. And then you write the production code. Now that test passes, and then you move on. But just with the way that the coding tools work, I haven't seen one that actually is able to do that progression of coding.
Yeah.
And so then I asked myself, well, is that still valid? Do we still want to do it that way? And if so, how do we get the tool? What's your view on that?
I think TDD especially can still be really useful, even if the AI is writing the code. There's obviously a scope issue there, right? If you just throw something at Copilot or Claude or Cursor or something like that and say, hey, build an application to do this, or here's an application, build this entire new piece of functionality, TDD is going to fall over a bit because you don't really know what shape that code's going to come out as. TDD is still really useful if you're asking Copilot or whatever other tool to write a function for you. Then you can work the same way. You can define what that function does first, write a test around it, or several tests around it, watch them fail, and then ask Copilot to do that work. I go even further as to say that it can even be helpful in those first stages. If you explain what you need this function to do and ask for some tests from Copilot, it can write some tests. You can look through those tests to make sure they are asking for what you expect them to ask for. You can even, ask Copilot to explain what it's done, and then even go further and say, are there any edge cases that I've missed with these tests? And then ask it to complete the code. If you start using loops, so if you do agent mode inside Visual Studio Code or Visual Studio, you could say, I want you to write the code to do this, and here is your function, header. This is what I want you to do. And then when you're done, go and run all the tests and make sure those tests pass. And if they don't, iterate on it until, iterate on the code to make sure the tests pass. So it's still test-driven development, but it's a kind of AI-assisted test-driven development. I think that's still, for things that you really care about, for functions you really care about, I think that's still a really good strategy. And, you can do it faster, I guess, and more, with a bit more help. Admittedly, where that falls over is when you're asking for larger pieces of functionality. If you don't have this entry point for your tests, then you can't validate that it's doing what you expect it to do. So if you're asking for much larger parts of pieces of work, then saying, run these tests when you don't know what the shape of that code looks like, that's a tricky thing. I would say whether you're doing it, whether you're asking Copilot or your Gen AI tool for entire functions or just lines of code, or on the other side of the scale, if you're asking for big pieces of functionality or entire applications, that depends on kind of how much you care about what happens if it gets it wrong. So if you're doing a little app for you and your friends to, I don't know, keep score of a game or something like that, it's probably not that important if it gets it wrong. Whereas if you are, for example, writing some functions or writing an application for your organization to move money between bank accounts, that's something you probably don't want to ask Copilot to write the entire application and then ship it to production. So there is this kind of balancing act that you need to be okay with the level of code that's coming back. Sorry, I've gone a bit of a tangent there, but I don't think that necessarily means that TDD is out of the question. I think it's just a case by case. If it's an appropriate technique for what you need to do, then it's still incredibly valuable.
Well, it makes me wonder. I'm not sure if it's a philosophical question or just what is the right structure of the industry, but if I do a survey at all kinds of other fields that have matured from infancy into an actual profession and an industry, just in the last 150 years, electricity. From the invention of electricity, and then somebody's like, this electricity thing. Well, if I run some wires, they didn't know anything about gauge wire or safety thing, or they were still arguing direct current versus alternating current. And so the very first electrical engineers, there was no difference between an electrician and an electrical engineer. It was somebody knew something about electricity and started running wires and started connecting things. And then, but you fast forward to today, and there's all kinds of standards, and there are electrical engineers who design the important things, and there are electricians that install things according to the design, and then you have maintenance electricians that fix little things that go wrong and replace fixtures and all that. And in our computer programming industry, it seems like we're still in that phase where if you're involved with the code, you kind of do everything. Maybe you do a little bit of engineering, a whole lot of construction and installing in a building, and a lot of servicing. And I'm wondering if we're going to start to have some separation between the engineers who design things and then some other, like the trade portion of the people that implement, and maybe it's implemented in a highly automated way. What are is that those kind of conversations going on at GitHub?
Short answer is I don't know. It's an interesting analogy, actually. I would say we're kind of still in the stage where there are a broad range of, to use the analogy, like electricians in the industry, and there are some who are along the side of, well, we've designed this entire electrical system and we can mathematically prove that it does what it's supposed to do and it's safe and so on, and here are the standards that we have around it. We have full code coverage. We build things and run our CI, run our tests, and we deploy to a staging environment, make sure everything works, and then finally go to a production environment and so on. And there's that side of the industry. And then there is the relatively newly created side, although not, I would argue, not entirely new, of people who don't have the education behind it, or they haven't studied software development, and you can throw a prompt at a tool and get something that generally works. And that feels a little bit like somebody turning the mains off in their house and then running some wires through the walls, and they turn it back on and the light turns on. They think, great, that probably works, with the danger of burning their house down that they're not entirely
right.
As for separating into those two industries, I think you might be right that we are likely going to see a bit of a separation of the people who have this mathematical proof or have the safety standards and things around the code, and then the people who just do the wiring themselves and cross their fingers and it's okay. And I would argue in some cases it's probably not a terrible thing to have people who just do the wiring themselves. I mean, if you're talking about a little breadboard that you have on a desk to turn some LEDs on and a battery, great. If that doesn't work, then it's not a big deal.
Right, low voltage.
Low voltage, it's not a critical thing. But if you're talking about somebody running, traffic lights on train tracks, for example, you probably want to know that that's going to work and it's not going to burn out and things aren't going to burn down and so on. And so then you do need the rigor around how you put these things together. And in that case, it's probably not appropriate to throw that prompt at an LLM and then, YOLO ship the code to production kind of thing. I worry a little bit that we keep seeing, especially on social media, even though a lot of this is probably rage bait, seeing people, building entire pieces of software and then just putting them live on the internet. And they haven't written a line of code. They don't understand the code. They don't know what's happening. API keys get leaked, people's credit card details might get leaked, all sorts of stuff happens because they're applying kind of an incorrect level of trust and understanding to a higher level problem or a more important problem.
Well, I think you and I are kind of the bridge generation. Some of the younger people didn't see this, but earlier in our careers, the internet was brand new. And companies were arguing over, well, does everything need to be connected? Why do I need to connect all these things? I mean, the concept of connecting computers, we don't even talk about it now because everything's connected. But in the late 90s, some computers were getting connected and others were just standalone, and floppy disks or whatnot, or dial-up modems sometimes connected. And there was a lot of people using Access and Excel and other things they weren't professional programmers, but they figured out enough scripting where they made something really useful And then the business came to depend on it. And I don't know if you did any projects in the early 2000s where some of those became mission critical. And then, oh, wait, it went down. Wait, what's going on? Oh, Bob's computer went down, and that's why the shipping dock can't send anything?
Yep.
It's probably going to happen again.
It wouldn't surprise me at all, actually. I'd almost expect it. And yeah, I've had those as well. I mean, I worked out in early days, there was a 2 gig limit to an Excel document, and I worked that out because we hit it, and that was there.
Yeah. Well, because 32-bit architecture, 2 gig process RAM limit.
Yeah. So the company switched to 2 different Excel spreadsheets for running the business. But that's also what I say by like the people who are not professional coders writing software is not a new thing entirely. It's a bit easier now, and you can do it with probably a little less knowledge than you could before. And so those aren't new problems, and I don't think the solutions are necessarily new either. It's a bit of a matter of scale. And I want to be clear as well, I don't think there's anything wrong with writing software like that and depending on software like that. It depends on what you're depending on it for, obviously. But, there's a small business could be running entirely appropriately on an Excel spreadsheet. And that's a great solution, and it works. Yeah. And frankly, the only thing that users care about is, does it work? And if it does, fantastic. So similar kind of thing with, entirely vibe coded applications. If it does the job and it works, that's great. But if it's a serious problem when it doesn't work, or, it grows to a point where suddenly there's a huge dependency on it and nobody really understands what's happening underneath, then that's when we start to get those problems. And again, not really a new thing. We've both probably seen that countless times, that this application that the company depends on, when you actually look into it, you find all sorts of potential issues and issues that you've actually encountered as well, that are worse than what we originally thought.
One of the new things, before we kind of run out of time here, there's so much going on with Copilot, and it seems like all the aside from OpenAI, all the Microsoft announcements are actually GitHub announcements. And so the Copilot SDK came out, and I know our teams are using command line, Copilot-P, and just putting it right in a PowerShell script. Yeah. And I mean, it's like, it's a whole nother way of using the technology than, let me pull up a chatbot, or just using it inside Visual Studio and doing multi-file edit. I mean, the SDK just come out. So what are you already using it for, and what should people be thinking about with the SDK?
I think so. SDK and CLI and the rest of those tools kind of just give you another, like a different surface to work on. And it depends what you like as a developer. So I'll be entirely honest here. When the Copilot CLI came out, I found that really useful for incredibly small little demos that I did. But if I was writing real code in an application, the idea of throwing a prompt at a CLI and getting a whole lot of changes that I didn't like, you can see them, you can explore them, but if you get 30 files changed, or like even if you get 5 files changed, that just accepting those changes was a little bit terrifying to me. But I realized that I'm just more comfortable with much more hands-on. So I'd be perfectly happy doing that inside VS Code with agent mode, where it essentially does the same thing. It's right there in front of you what those changes are.
Right.
But then I spoke to a bunch of engineers over at GitHub, and they love the CLI. And I think partly because they've developed that level of trust of, this is what it's going to create. These are the limits. They've built, custom instructions and all sorts of stuff around it, so they can trust it a little bit more. But it also allows for, there's two things. It allows for some new paradigms in being able to do that work. The kind of hands-off, go do this thing and I'll come back and check on you later, which allows you to do things like, that we couldn't really feasibly do before. Like, I've got 3 ideas for implementing this. Can you go and just run those 3 ideas, and I'll go and work on something else? And then when I come back, I'll examine that work and say, okay, this one clearly didn't work. That's a good idea. But then there's this little piece from this third one. Okay, we'll use those pieces. Now that was possible before, but it wasn't really feasible. It takes you 3 times as long. You have to be able to roll back and try the next one and so on. But that allows you to kind of put that work forward. The other thing I'd say is as well is that engineering inside GitHub, obviously, there is a lot of that process around the code that goes in. Nothing's getting YOLO'd to production. There's entire tests. There's a huge amount of rigor around it that already exists. And so even if you did, and I'm not saying that they do this, but even if you did throw a prompt at an LLM and then just commit that change, there is a lot of rigor around whether that code is actually going to make it to production or not. So there is that safety there as well. I think so. The SDK and things like that just gives you another surface for being able to use tools like Copilot in a way that you're comfortable with. Personally, I'm still going to, for the moment, stick in an editor, VS Code or Visual Studio. But for some pieces of work, I've found just assigning an issue to Copilot to do a really good job. Or getting most of the way in a pull request and then assigning it to Copilot to say, hey, can you finish this off? This is all I need to change. I'm becoming more and more comfortable with that as well, particularly because I know I have kind of the CI and the testing and the advanced security, checking for security vulnerabilities and things around that work as well. So I think that's just as important. But yeah, that's kind of what we've been seeing. People using it for. They're doing it in a way that they're comfortable with, and the fact that there's a lot of these different surfaces means that you can choose how comfortable you are with just allowing it to go and do the work.
Yeah. Well, what I wonder is, like with GitHub and serious software systems, you have all of those tests. Surely somebody at GitHub says, you know what? Here's an issue. Man, we could assign this issue to the junior most person on the team. It's not hard, just needs to be worked on. Probably take me an hour, maybe an hour and a half if I have to figure out what part of the code. Let me just define the issue. Let me just hit, Windows H or transcribe. Let me just kind of talk something about, all right, we need to do this. This is how to approach it. It's probably in this area. These are the symptoms of the problem or whatnot. And then just assigning that to the Copilot SWE agent and go to lunch on a feature branch. Worst case scenario, you throw away the feature branch, right? And then you go to lunch, come back. What did it do? I mean, best case scenario, okay, I like the code. Worst case scenario, you throw away and you have to do it yourself. I gotta imagine a lot of that's going on just organically.
Yeah, it really is. It happens a lot. And I think that the key here is suddenly we've got this abundance of time. Yeah, time is no longer the limiting factor when writing code. I was speaking to an engineer on the Copilot team. So interestingly, they use Copilot to write Copilot a lot of the time, or to assist, obviously. But one of the engineers I was speaking to said that in the morning they look through this backlog of issues that they want to work on, find 3 or 4 where they know Copilot can make at least a good start on them, and then assign them to Copilot, and then find the one which is maybe a little bit hairy or a little bit requires a little bit more concentration, or frankly is just a little bit more interesting to work on. And they will work on that one while Copilot is going and doing the work. And then very similar to the way they used to work with human code reviews at the end of the day, they will get to 3 p.m. or something like that and say, all right, let's see what's happened. And they will look through the pull requests that are being created. And just like you said, if they're no good, then you can just throw it away, maybe adjust the details in the issue. So if you do it again, it might have a better chance. Or if it's getting some of the way there but needs a bit more context, you can provide that context. You can do that while it's working as well, actually, if it's still going, or if you check on it 10 minutes later and you need to steer it in a particular direction, you can just make that comment and it will steer it. But it means that, best case, you get this, great implementation that has everything you need in it. Worst case, it's terrible, you throw it away. And there's a lot of middle ground that saves a lot of time. So yeah, they are definitely doing that. And we hear the same thing across a lot of companies as well. You get this abundance of just being able to scale yourself essentially as a developer, and just do a lot more work with the same amount of time.
Well, GitHub is kind of started out as just a Git hosting company and then has moved into other adjacent parts of the software development lifecycle. From a vision perspective, is GitHub trying to provide for the whole software development lifecycle, or is there like, nope, before this part, it's not us. We're going to stick to what we're good at, or what's the plan?
I don't think there's a really solid answer for that. I think there's a lot more collaboration. Well, I know there's a lot more collaboration at the moment between GitHub and Microsoft. So there's, for example, one of those spots where GitHub kind of stops is, when your code is in production, what do you do?
Mm-hmm. Operations
side of it. Yeah. But I mean, even at the last Ignite, we announced there was an integration between Microsoft Defender for Cloud and GitHub Advanced Security, so that stuff that's running in production can get tied back to the actual code that changed and the security vulnerabilities to say. So when you have a look at the things picked up in advanced security, you can say, well, this one is actually running in production because we have that information from MDC. So that integration is helping. So there's kind of a little bit more of a gray area, I guess, between what parts of it are GitHub and what parts of it are Microsoft. The appropriate place for that feature or that function, I guess, is where it belongs, and we work really, really closely with Microsoft on those things. And then in other respects, like the earlier stuff about specifying the problem before you hand it off to GitHub, to Copilot, things like SpecKit or just those techniques as well kind of pop up in the industry as well. And then depending on whether there's something that we can build into the products or whether it's something that the community is working on itself, then we take appropriate action there. So SpecKit, I think, is still entirely valid. The idea of going through these stages of defining what you want and then writing specifications, breaking it down into tasks, and then completing those tasks individually. That was something that was, kind of created, I guess, kind of outside our engineering teams. But then since then, it's been a common paradigm. So it's now kind of part of the planning mode in VS Code, in Copilot, and then, agent mode and so on. So you have these ideas that kind of work their way into the products. As for, where we stop and say, this is not appropriate or this is not what GitHub is going to do, I don't know if we have a firm answer on that. I think we just kind of, without being the person who sets the strategy, I think we kind of look at what the industry is doing and pick up the good ideas and the way that people are working. And then, we experiment a lot. So Workspace, I mentioned earlier, but Spark was one of the earlier ideas, which is very much consumer vibe codey. Give me a description, and the code is very secondary. It's not dead, but it's kind of on the back burner a little bit. But it's a great way of working. It's just maybe not what we're focusing on at the moment. So yeah, I don't think there's any hard lines that we won't cross. I think it's just a matter of what the community needs and what we think is appropriate and what we can help with the most, I guess. Yeah.
Well, as we close up, you mentioned something, SpecKit, and GitHub has an issue. Yeah. Conceptually, you can do whatever you want, but it's an issue is an issue, and you can give it labels. And then you have GitHub projects, which is seemingly disconnected, and you can have a Kanban board, but you can trigger a GitHub action off of an issue and a label change, but you can't trigger an action off of it moving on the project board from one of those stages to the other. And so you mentioned SpecKit, which I think a lot of listeners never heard of it, created as an open source project by some people at GitHub, including I think John Lamb, who's really influential in the Iron Ruby era when dynamic languages might have been a part of the C# or the .NET ecosystem. But can you expand a little bit more on SpecKit and why someone might be interested in checking it out?
Yeah. So one of the complaints that I think people have of the whole vibe coding movement is that you're really relying on the Gen AI tools to kind of assume a bunch of information really correctly. So if you're asking for an entire application, how do you describe that entire application in a few sentences? And you can write these gigantic descriptions of what you want, but there's kind of a balance between the scope of the change you're asking for and the accuracy of what you're going to get out the other end. So in some cases, you might be able to define what you want in a few sentences, but in other cases, what you get out the other end is going to be close, but not exactly right. Or, you have to limit yourself to a small part of what you actually want just to get a reasonable result. So SpecKit kind of helps you, or that paradigm, I guess, kind of helps you get over that issue by working very much the same way that you would as an engineering team anyway. So at the start, your job is to define, your requirements. What do you actually want the application to do? And what SpecKit allows you to do is in that first stage, work with generative AI to create this requirements document, or a PRD is what we all often call it, a product requirements document. And it will create this big markdown document, I think it's markdown, with all of the details of exactly what this application should do and what it shouldn't do, and what you care about and what you don't care about. The important thing is that you're not just throwing that at an LLM and then saying, great, this is what we've got back. You are iterating on it. You can make the changes to the document yourself, or you can ask for changes from whatever LLM tool is using SpecKit, I guess. So you're iterating on this requirements document until you think, okay, great, this is a good set of requirements. And then you go and create a specifications document, which takes those requirements and adds a bit more technical detail into them. So very much the same as we would have done with traditional software development. And then same thing, you iterate on that, you edit it yourself, you ask for edits from AI, and then you break that down into tasks as your next stage. And so then you attack the tasks individually. And what that means is by the time you actually get to the implementation stage, you've done all of the work to make sure that it's asking for exactly what you want. And the scope of the change that you're asking for, code to be generated is relatively short because you've got these small tasks, you've broken them down. So all the way through ideation, all the way through to the actual implementation is done, step by step in a very kind of reliable way that kind of mirrors what we do as software developers traditionally anyway. And what we find with techniques like that is we just get a much better result. It takes a little bit more time, but there's a lot more rigor behind it. What can be great about using a technique like that is that it's not just a one and done. Once you have that final application, you can say, I want to add a new piece of functionality to it. So you start with another requirements doc and another spec and another set of tasks and then so on. So you have this kind of growing living set of specifications and requirements and so on that live with the application when you make those changes. Almost like the documentation is living with the app.
Built in.
Yeah, it's built in. So, and you don't have to use SpecKit necessarily, but it's a great way of doing it. Keeping these documents alongside the code that you're actually writing.
Yeah, that's really cool. There's a pattern and a problem that's been talked about over time called architecture decision records. It's the question of, okay, we made a decision about some type of design aspect of it. How do we record it? What is the mechanism whereby we put it into documentation? So it sounds like this open source project covers that need as well.
Yeah, it's definitely very similar to that. The idea of having human readable, this is what we decided on, and then the implementation as a result, living kind of side by side is really handy for looking back as well. So seeing what happened on the life cycle of this project.
And then having it in the same Git repository natively makes it easy and automatic for all of the AI coding tools to pull it into context and do the right thing more frequently.
Yeah, exactly right.
Awesome. Well, Damian, thanks for coming back on the show and catching us up on what's going on with AI at GitHub. I really appreciate it. Lots of stuff going on.
Definitely. Yeah, no, pleasure to be here again.
Awesome. Thanks so much. And until next time, dear listener, keep shipping.
You've been listening to the Azure and DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and anywhere you get your podcasts. Visit our sponsor, ClearMeasure, at www.clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.